Good evening to everyone. So we are seeing the boiler water level sensors. And the next one of this one, two we have already completed yesterday, that is this. So this one and this one we have completed. Now today we'll see these two. So let's see about the C. This is the float with magnetic switch. Float with magnetic switch. So if you see this one, magnetic switch, float with the magnetic switch.
बाबू तो बाल कटा नहीं है मैं क्लास लिया को दे देगी आधे घंटे
Okay. Now here you can see this is a float, level float. This one is a level float. And here there is a float rod. So this connecting rod or float rod. And this one again, this is a float rod. And this one is a magnet. It is a magnet. So with the level float rod and the magnet that is connected together in a transmitting tube. So this is a transmitting tube where it is being connected. Then we are going to have a magnetic switch. Two magnetic switches are there. These magnetic switches are also known as a reed switch. You might be knowing on board ships, you might have seen this. So there is this reed switch is going to work in this way. Now suppose this is a magnet and now suppose this has passed from here. This will change the status here, means it is going to connect from here to here. You can see this one. This is how it is being connected, this circuit. And once it is going to reach, again it is going to connect here like this. 1 and 2, that is being connected. So it will pass here. Now when it is going to come back from here, like it is going down, in this case again the status is going to change. Okay, this status will change. So this status changes every time when the magnet is passing. Magnet is going up, it will go to this side, and when it is coming down, it will again come back to this side. Here also the reed switch is going to happen. It will, when the magnet is moving up, this will move this side, and when it is going to come down, it will move this side. Okay, so it is status is change, and this magnetic switch, how it is going to work. And this magnetic switch is going to give the alarm, or we can start. No, no, no. Barun, do not write anything. You are writing on my OneNote. Barun. Okay. So just wait. Okay. So here it is going to give, means this switches, if number of switches we are going to put here, it is going to give the alarm or pump can be start and stop. Start and stop. So this is how it is going to work. So this is the float switch. This is how it is going to work. So now again, this is going to give the on and off signal. On and off signal. So wherever we are having the on, this is not a continuous one. So it is going to give a discrete signal or the on off signal. That is what we know. And that's why it is going to be used for the on off control. It is going to be used for the on off control. It is going to be used for the on off control. Like here we have seen this one capacitive type. It is used for it is going to give a continuous signal. So this is used for the continuous control system. Continuous control system. Sorry. Now next we are going to have the variable type, variable resistance plot type we are having. So variable resistance plot type. So we do have the again same arrangement, only in place of the reed switch, we are going to have the variable resistance. So this is the resistance you can see here. This is the resistance that we are going to have. And this resistance we can have the output. So there is a variable output from 0 to 24 volt we can have. And if we are going to have a variable output, this is going to give a continuous signal. Remember, it is a continuous variable output. It is going to give. And if it is going to give continuous variable output, that means this can be used for a continuous control system, continuous control systems. So with this, we can use for start and stop of the pump. Again, we can use for the alarm purposes. So this is also can be used. Okay. Working principle is going to be same. Now there is a last one that is DP transmitter. So if you see the DP transmitter here, this is a DP transmitter. Okay. Now if you see the DP transmitter, there are the many questions that is being asked in this DP water level transmitter. Many questions. The first question it is going to come. What is DP transmitter? Okay, the first question is the oral, it is going to be asked. Second, which leg is high pressure and low pressure. Okay. This is the third question. Third is how to or working principle of this. Okay, that is the same working principle of this. Fourth, how to calibrate. So how to calibrate this one? So working principle and how to calibrate this. And if you know the how to calibrate, then how to test the alarm. Test the alarm. So this is what the DP transmitter or DPT. This many questions is going to be asked in the oral, and it has been asked. And people have really failed in this one. I'm not just giving you like this, but people have been failed due to this because many questions they are asking in this one. Okay, now let's see all the answers. We'll try to see this one. First of all, what is your DP transmitter? Okay, so DP transmitter, again, where the words transmitter that is going to come. As I have told you, there is going to be the DP cell plus the signal conditioner for the transmitter, signal conditioner. The signal conditioner is nothing, but it is going to give the output at 4 to 20 milliampere. Okay, this is going to be a standard format output. It is going to be, or it is going to give 0 to 10 volt DC. So that is the DP transmitter. Basically, it consists of DP cell and one transmitter, which is going to give a standard format output. Standard format output. Standard formatted output. Okay. Now, what all things we are going to use in a DP cell? What is DP cell or how it is going to work? So that is the question basically. So DP cell are the three types generally that is being used in the DP cell. So one is a piezoelectric. DP cells are there, and the strain gauge and third is capacity. So generally these three types of DP cells that is there, and most commonly used is the capacity. Remember, this capacity is most commonly used DP cell, most commonly used. Okay, so try to see this one, DP cells, how it works, capacitive, strain gauge, and piezoelectric. Now, the DP transmitter, whichever it is there, whichever the cell it is going to use, it is going to have the two pressure line connected to this one. There is going to be two pressure line that is going to be connected here. Okay. Now, suppose we are going to use a capacitive type, and suppose this is a capacitive type here, like this. So the output that is we can take from here. This is the wire where the output will be there. Okay. So this is going to give a difference of the electrostatic, this is the capacitive type. So electrostatic charge will be there. As per that, it is going to give the output. So this is going to give 4 to 20 milliamp. It means after the transmitter, it will go to the transmitter and transmitter is going to give this output. Not the DP cell. DP cell do not give the 4 to 20 milliamp. Of course, there has to be a transmitter and the transmitter is going to give the output from here. So it goes to the transmitter and from the transmitter, or let me write here the transmitter. So it will come, this output will come to the transmitter. And from the transmitter, we are going to have the output that is the 4 to 20 milliampere or 0 to 10 volt DC. 0 to 10 volt DC. Now this side, we are going to have a pressure that is, will say P reference. And this side, we are going to have a pressure that is the P major. Okay, P reference and P major. So P reference, so P major is going to give the pressure with respect to the P reference. That means there is a differential pressure. So we are going to have P reference minus P major. So this is the how it is going to give the output. This output, differential pressure output, we are going to get. So generally, this P reference, this is a constant pressure always. It is not going to change. It never changes because it is a reference. Reference should not get changed. Okay, this is a reference. Reference should not get changed, remember. And the P major, which is there, this P major, this is a variable one. This is a variable. So if it is going to vary, of course, the output, that is the delta P, this is also going to vary. It is also a variable. So this variable, and that's why we are going to get the output 4 to 20 milliampere. And that's why the difference between the pressure, if it is a variable, it can be converted into the current 4 to 20 milliampere. And we know that how much the pressure is now. So at what level? So this can be used as a level measurement of the water. Level measurement of water. So this DP cell, this is a DP cell, capacitive type, what I have made here. Capacitive DP cell. So this capacitive DP cell or any DP cell that is going to have two pressure input and it is going to give the output and accordingly it is going to give the output 4 to 20 milliampere. This is how it works. Now coming back to this one. Okay, coming back to this. Here we are going to have the stream pressure. Here we are going to have the stream pressure. Okay, and here the water level is there. This is the water that is filled. This is the valve. This is always going to open. It will be open. Okay, this will be open. Here, this one is also going to be open. So both are open, and this is a drain valve. So these drain valves are always closed. So this is closed. This is also closed. There is a equalizing valve. If you see here something equalizing valve at the center, this is also remain closed. These two connection valves are there. Okay, this is a connection valve. So this will remain open always. Okay, so it is going to remain open always. It is going to remain open. So these two are remain open This will be closed. Here also it will be closed, closed, open, open. Now we are going to have the two tanks. There is a two tanks are there, and these tanks are known as a condensate tanks or the tanks. So these tanks are having filled with the water. So this is a condensate tank. Okay, and here also there is a one tank you can see. This is a condensate tank. And this will be filled with the water. So just I am writing here. Condensate tanks are filled with water. It is filled with water. Now, as I have told you, this is going to be a reference lake. So these lakes are reference lakes, and this lake is a variable lake. So now you can see this is going to be a pressure reference, and this is going to be a pressure measurement. Now, question is which is going to be a high pressure lake and which is going to be a low pressure lake. Can you tell me which lake is going to be high pressure lake and which is going to be low pressure lake? Yeah.
The reference is high pressure.
Sorry.
Reference leg is high pressure leg.
Reference lake is a high pressure lake. Okay. Anyone else? Okay. Why the reference lake is a high pressure lake?
Because steam pressure is more than the water pressure, sir, exerted on the.
Anyone else? I hope there are the many candidates are there. 21 candidates. Only one candidate is replying. Okay.
Maybe you talked about this to shrinking effect and swelling effect because of that.
Sorry?
You are telling now this shrinking effect and swelling effect, it is on the water level only, maybe.
No. That shrinkage and swelling effect. No, I am asking which leg, which leg like this one is a leg and this leg. Which leg is going to be high pressure leg and which is going to be low pressure leg. It is nothing to do with the swell and shrinkage effect.
So is it possible it will be changing all the time?
Sorry?
Will it be changing like when the water level is low, the pressure will be low there. Water level is high, the high pressure side will be there. It will be changing like that.
Okay. If it is going to change, then how you are going to get a difference? How you will be getting this? Both should not change, only one should change.
Okay.
No? Reference leg is the reference leg. It is should not change here. Can you see this one? This is a reference leg. It is written very clearly.
No, sir. I'm saying that reference leg can be a low pressure and a high pressure according to the situations.
No.
Okay.
No. Okay. The candidate who has given the answer that reference leg is a high pressure leg, absolutely right, but justification is wrong. How he justified that is wrong. Okay, this is not due to the steam. Steam pressure because it is a closed vessel. Vessel means drum, container. It is a closed container. And in a closed container, the pressure is equally divided, means it is equally applied on the sides. It is a steam pressure here, the pressure of steam. So it will be applied all the sides equally, not only this side, but in the water also steam pressure it will be applied. Yes or no? Okay, it will be there. That means it will get cancelled out. When we are going to do the differentiate between the P reference minus P major, steam pressure will cancel out. Because it is applied here also, it is applied here also. Same. Okay, so that is a constant pressure. So it is going to get cancelled out. Now only remaining that is a P reference and P major. Of course, this is a high pressure and this is a low pressure. But this high and low pressure is there due to the height. Due to the height. And this due to the height that is known as a hydrostatic pressure. Hydrostatic pressure. This pressure is there due to the height. Okay, so which tank is going to be at more height, that is going to have the more pressure, and which height is going to be less, it is going to have the low pressure. So this leg is going to be a high pressure leg, whereas this leg is going to be low pressure leg. But it is situated here and the water level of this one is not varying. You can see this is the water here. But this water is not varying. That's why it is always going to be a constant pressure. It is going to give a constant pressure. That means HP is a constant pressure. Always. It is not going to change. Whatever it is there, it will be there. Now, this pressure, because here the valve is open and this boiler drum, this level is changing here, this level. It is going up and down. And that's why this is a variable leg, it is a low pressure, and this is a variable pressure. So this pressure is going to be variable. This pressure is going to be always variable. Now we can have an output here. So this is the output. What we are going to get differential pressure output and differential difference. Differential means difference pressure output we are going to get. And that's why we are getting this output 4 to 20 million. So 4 to 20 milliampere that is going to give a level measurement of the water. Now we need to calibrate this one to get a 4 to 20 milliampere. So how we are going to calibrate this? During the commissioning or whenever we are going to change the DP transmitter, we need to calibrate this. Okay, so how we are calibrating? So let's see about this one. If you want to take a screenshot of this, you can take it because I am going to rub it now.
Sir, can you repeat the high pressure? How is it keeping constant?
Because this level of this one is not changing, so it is going to have a constant pressure. And here the water level is changing of this boiler. So this leg is going to have a variable pressure.
Okay.
Okay. You can take a screenshot. Okay. If you have taken, then I'm going to rub it. Now, how to calibrate? So calibration already I have told you. The calibration part yesterday only I have told. That was that if the transmitter is there, suppose this one is a DP transmitter, this is a DP transmitter. Then we are going to have two potentiometer. One it will be written 0 and here it is going to be the span. So there is going to be the connections and the connections are going to come out from here and it will go to the controller So this part we'll say it is a controller. And we are going to give a power supply here. Like this. So here we are going to have plus and here we are going to have the minus. That means here it is going to be plus, here it is going to be minus. So this will be the power supply. Now already I have told you we can break any position. So suppose I am breaking here. Okay, and I am putting my multimeter milliampere and okay, this is the connections. It is for drop. So here we are going to put a multimeter. So now put your label. We must put wherever we want 4 milliampere. So suppose if I am going to put this one, this label, and in manual also it is given, just bring it up to here, this position. Okay, this position we need to bring, and it should read 4 milliampere here. So if you are going to read the here in the multimeter, it's supposed to read 4 milliampere. If it is not reading 4 milliampere, then adjust by the zero potentiometer. So this is the potentiometer here, 0. It should be adjusted with that. Now next one. Again, you have to raise this potentiometer, this water level up to here. And here it's supposed to read the 20 milliampere. This water level, you need to raise this one up to here. And this supposed to read 20 milliampere. So this is a proportional band. Okay, PV we are giving here. So now it's supposed to read 20 milliampere. If it is not reading this multimeter in the milliampere mode, so we can adjust with the span. We are going to adjust with the span. So this is how we are going to do the calibration. And when the water level is going to be at the normal water level, NW, you can see in the level gauge, level gauge. And if the water level is NW, it's supposed to read, if you have done correctly this adjustment, it's supposed to read 12 milliampere. Okay, it's supposed to read 12 milliampere. It's supposed to read 12 milliampere. So this is how we do the calibration. Now we can have a different level. We can have the alarm or we can have the start and stop of the pump. Let's see how we are going to adjust that one. Now suppose if it is going to read here 12 milliampere at the center, this is a 12 milliampere. We can have very precisely, we can do like 14 milliampere, 16 milliampere, and 18 milliampere. Then finally 20 milliampere. So 14 milliampere, 16 milliampere, 18 milliampere. Then 10, same way 8, then there is going to be 6 and 4 like this. What we are going to do at the 10 milliampere here, at the 10 milliampere, we can, like if it is a start stop, on off control if we are making it. Yeah, one thing you should remember that we are going to get a continuous signal sensors we are having. This also can be used for the on-off control. On-off control. Remember, okay, we can use this one as a on-off control. Like we are using here. It is very much, it is going to be used for a continuous control, but it can also be used for the on-off control. So here, suppose if we are going to use for the on-off control, then like 10, at the 10, we are going to start the pump. Then at the 14, we are going to stop the pump. This is just for an example I'm quoting here. Okay, it will be working like this if it is a start and stop. Then at the 16 milliampere, it is going to give the high level alarm, and at the 18 milliampere, it is going to give you the high level alarm. Same way, if the 8 milliampere, it is going to give a low level alarm, and at the 6, it is giving the low level trip. Low level trip. So HL or LL, this is the low level trip, low level trip, and this is the low level trip. Low level alarm. Low level trip and low level alarm. So like this, it can be used. And if it is a continuous signal, of course, the continuous signal will be going, and we can use for the various alarm purposes. Okay. Now, that is the how to calibrate and working principle. This we have completed. So this is completed, this is completed, this is completed, and this one is completed. Now, how to test the alarm? And this question is asked because if you have worked in the system, then you must tell, because you will be doing this one. Okay, you might have tested. So how you are testing this one? Can anyone tell me how you are going to test it?
So by opening the drain valve,
Which drain valve?
this is the low pressure one.
Low pressure one. Okay. Then
Closing the closing and opening the drain valve.
okay, that drain wall you are going to open. So you will get only the low water and low water level. Correct, no? But
Yes.
what for the high water level and high water level trip?
We will shut off this shut-off works with both, and
Sorry,
then
come
by
again, please. Come again, please.
shut-off walls we will close first.
Yeah, that is okay. Setup wall we have closed now.
Then for high level, this filling plug we will use. Then in the reference we will fill, so it will show high level alarm.
You are going to fill the water here, so it should show the high level alarm, correct?
Yes.
No, but water is already supposed to be filled always.
No. If
Trying to fill
I'm
this water.
supposing if it is empty, okay, but it will be there only.
No, it is not empty. It is already there. Water is supposed to be filled. Then only you are going to check this alarm. Otherwise, the alarm is going to come wrong, because P reference supposed to be always constant. And it is going to give you a constant value, P reference, high pressure, when the water level is filled 100%. Okay. First of all, by opening the drain, here you are going to close this set of valve, and by opening this drain, we should not carry out test. If you are going to open this one, okay, because this side it is going to be a high pressure, and this side there will be no pressure. No pressure means, now remember, the steam role is going to play here. steam roll. Can you see the steam? Now suppose the steam pressure here. Steam pressure is also there. This side, this side, this side, all the sides. Now here there is a P reference plus P steam, and P steam is very, very high. Okay, it is suppose if it is a 8 bar is quite high. And if you are going to close this one, okay, and you open this, you are releasing the pressure, whatever the pressure is there, steam pressure. When you close and when you are going to open the drain, you release the steam pressure. Only the P variable or P major pressure will be there. So that is as per the height. That's it. Otherwise, it is pressure is released, and this height is only up to here. So of course, this is going to give you the, if you just drain it little bit, you can measure the L and low water and low water level, but exactly how much it is going to come, you will never come to know. That is the one thing. Okay, at what level it's supposed to come, you will not come close here. But you can test it. I am also saying you can test it. But remember the second point is you are going to damage the diaphragm. Okay, diaphragm. This is the diaphragm. The diaphragm is here. Can you see this one? Here. You are having a full pressure this side, and this side pressure is not there. Okay, this is going to bulge and permanently it is going to damage. Remember this. Okay, and people have damaged the DP cell like this of the boiler. So you should not do anything from here. So if you are going to release, the steam pressure, you should drain from here also if you are having any work. Okay, and thereafter you should drain from here also little bit. So your P steam is drained. Now if the P steam, this pressure, steam pressure that is 8 bar, that is drained. Okay, then you can close it, and thereafter you can do the checks or something. That is okay, you can do it thereafter. Okay. So never do anything from here, the drain wall, and if you are going to do, very cautious you have to be, because there is a steam pressure both the sides, this side also and this side. If you open the drain, this side is steam, because this side is very high pressure, P reference plus steam pressure. And here your steam pressure is out. Only P measure will be there. So it can damage the DP transmitter. So basically then how to calibrate this one? The calibration is done basically, okay. What you can do is, the best way to do this one is actually you must vary the water level. So if you vary the water level actually in manual mode, okay, manual mode, you little by little you vary the water level, and you can check all the levels. Okay, all the levels you can do it in this way. Second is just close from here these 2 points. Little bit you drain, so your this steam pressure is out. And here also you can drain little bit, so steam pressure is out. Or if you are not able to drain, suppose because you need to go on top, and because the drain is coming, one pipe is coming up to down below in the boiler, you might have seen. So you can drain both little bit, so your steam pressure is not there. Open the connection from here, and put a pressure calibrator. Okay, so pressure calibrator that is there, and little by little you can increase the pressure. So once it is, you can note also what is the pressure. It is going to give the high level alarm, and what is the pressure, it is going to give the high level trip. And same way, if it is going to be the low level alarm and low trip. So you can, once you do it, you can record. One is the actual procedure, that is how you are going to do it. Second, discharge or drain the steam pressure, okay, or release the steam pressure by the drain valve after closing this, and open from here and just connect your pressure calibrator. With that also you can do it. Okay, with the pressure calibrator also you can do it. Actual is always good one, but there is a problem. Nobody will allow you to do this one because there is going to be a problem with the thermal stress. You cannot put a cold water continuously in the boiler drum. Otherwise, it is going to damage the tube. Due to this thermal stress, you need to do it, but it will take time. Slowly, just you can increase the level in manual mode. Keep water level in the manual and try to keep on increasing little by little. It will take time to go up to the high level trip. Because continuously pump you cannot run. Same way, if you are going to drain out, lot of water is going to be wasted. Okay, so that is not recommended. How you are going to do? With the drain valve only you are going to do for the low level and the low level tip. With this only we are going to do. Again, I am telling, close this. Here the drain valve is there. Release some of the water from here, and thereafter you can release from here also. So steam pressure is out. And thereafter you drain from here and you can check the low water and low water. So that alarm will come, but you will not come to know exactly where this alarm is coming. At what point it is coming, you will not come to know, because actually you are not doing, and actually nobody is going to allow us, because lot of water is going to be drained from the boiler drum. So that is generally nobody allowed. And second, after the draining, when you are going to fill up the water, it is a cold water. Okay, so that is also people are not going, this engineers, they are not going to allow you to fill up so much water in the boiler. So best way, the pressure calibrator that comes. So with the pressure calibrator, you can check the high level alarm and high level trip. Okay, this you can do. Otherwise, actually, if they are allowing you, it is the best way you can. Hope you have understood this one.
So I did not get how to check high level alarm.
How to?
So how to check high level alarm using
How
pressure
level,
calibrator?
high level alarm, that is what I have told you. You can go for the actual, if it is allowed, if they are allowing you to check this one actual. So start the pump, that is a feed water pump in manual mode. Okay, and let it be filled. So from here it is going to rise only, but you need to be very cautious here. There is going to be a problem with the thermal stress, so you cannot fill the cold water. Cold water means hot well water. That is at 95 degrees centigrade, and the boiler water, that is almost 200 degrees centigrade. Okay, almost this water temperature is going to be 150 near about. So this 95 degrees centigrade becomes a cold water for this boiler drum. Are you getting me? So this becomes a cold water, although it is a 95 degrees centigrade, but it is a cold water because the water temperature here is quite high. It is 150 degrees centigrade. So you need to slowly you need to fill this water. So there will be no thermal stresses. Okay, and once you are going to reach to the high level, this alarm supposed to come, and again, if you continue this one, then high trip will also be there. High trip will also be there. Okay, hope it is clear.
Yes, sir.
Yeah. And same way, if you blow through means the remove the water. Okay, in that case also, we are going to get the signal of the low water level and low water level. Okay. Now, next is, then what is the role of, you might be thinking, then what is the role of the equalizing wall here, this part. So let's see about this part, equalizing wall, how we are going to do. Okay, equalizing wall. What is this? So this equalizing wall, you have seen the equalizing wall here. And the role of this equalizing wall is during when you are going to replace this DP transmitter and when you are going to replace means when you first you need to remove this, then again you are going to put a new one. Okay, so that time the work of this equalizing wall is going to come. So how it is going to come? First of all, you need to remove this. So removing is having a sequence. Removing of DP3. So there is a sequence you need to follow. So first in this sequence is close the LP wall. Close the LP wall. So this is the LP wall. First we need to close this one. This was closed. Huh? Okay. First let's understand. This was open. This is open and this is closed. This is the situation. Now I want to remove this DP transmitter. When I am going to remove this DP transmitter, first I am going to close this. Okay, so this is the first what I am going to close. Second, open the equalizing wall. So this wall is open now. So if it is open, now whatever the pressure is this side, same pressure is going to be here. So it is equalizing both the sides. So whatever the pressure you are having here, okay, like suppose P major, and here we are having the P reference. Now this P reference and P major both becomes equal. So it is a equal pressure. So if you see here the signal, there will be no difference. So dP is going to be 0. dP, differential pressure, is going to be 0. So at this particular point, we are going to have a 0 pressure. And that is the reason why we are going to use this equalizing wall during opening. Otherwise, we are going to damage this. The diaphragm is there, that is going to get damaged. Then the third, close the HP wall. Close the HP wall. Okay. Now, how to put into service, that is the DPT, we need to put it. So putting back or putting a new DPT, because you are going to open for some maintenance purpose or something is there, and again you are going to put it back. So just do the opposite of this one, opposite of this first. As you have done the fitment. So now the condition is something like this. This is open, this is closed, and this is closed, like this. So first we need to open the HP wall. Just we are going reverse of this one. Second, we are going to close the equalizing wall. And third, we are going to open the LP wall. Thereafter, you need to do the calibration. Okay, thereafter, you need to do the calibration. So this is how we are going to use the equalizing wall. Clear? Any doubt to anyone?
So I had a doubt. Removing first step, when you said close a low pressure valve, right?
Yeah.
Right after that, I mean, before opening the equalizing valve, it won't damage the diaphragm.
No, no, because you are not relieving the pressure. No, you have just closed the wall.
Okay, okay. Got it.
Okay. Here, what you are doing basically, if you are closing this shuttle valve and when you are going to open here, your steam pressure is out. And this side, still the steam pressure is there. You have not relieved it, the pressure, because it is closed here. In this case, this will get damaged.
Okay.
So this is how we are going to do the calibration and service, what is the equalizing valve and all. So this is when it is going to be, when the removing and putting back the BPT. This is a very important one. This should not get leak and do not open it. Otherwise, there will be the error in the signals. Now let's see about the boiler on-off control and boiler continuous control. So there are two controls. See that one. Already I have told you there are two types of, in the auxiliary boiler, we are going to have two types of control, and one is known as a on-off control. You can see this is a on-off control. Yeah. Okay, so this is a on-off control. You can take a screenshot. This is a very simple one. So we are going to have a level transmitter, and generally the level transmitter what we use, that is a discrete signal which is going to give a discrete signal. Discrete means on and off signal which is going to give. That is the level sensor we are going to put here. So it is going to give either the start signal or it is going to give a stop signal. So this is a pump stop and start signal. This is known as a discrete signal. It will come to the boiler control panel, and from there it will go to the feed pump starter panel. Sorry. Or directly this level transmitter will go to the feed pump starter panel. It can go or it will rotate through the boiler also. And this pump is being on and off as per the required level. Okay, it is going to be on and off. Now, next is, so this is the on-off control. And next one, we are going to have the continuous control. And generally, in the continuous control, you might have seen like this. This is a continuous control. Now, if you see the continuous control, the level transmitter generally we are going to use, which is going to give a continuous signal, level signal, it is going to give. like capacitive type, DC transmitter, float with the variable resistor. These all are the continuous signal which is going to be. So such level transmitter will be used. We are going to get a continuous signal. So this is the continuous feedback signal. Feedback, water level feedback is there continuous. Okay, then this is going to the control output. So here we are going to use the PID control or PLC control. So we are going to have continuously a control output. So this is also a continuous control output will be there, which is going to vary the feed control valve. Now your pump, these pumps are running continuously. Continue running. Okay, so one pump and one is standby. One feed pump is continue to run. This is going to be adjusted continuously as per the required level. So the flow of the water is being controlled. Now, if this feed control valve is having an issue or any in the closed loop system, like your sensor is failed, or the PID or PLC is not working, or this valve is having an issue, then for the redundancy purpose or emergency purpose, we are having this manual control valve. So we are going to control with this the level. So we just open on the trial and error basis and we are going to adjust this level. Then we need to watch this one continuously. Okay. Now, second thing, if suppose the feed control valve is closing this one, if the level is rising and this will try to close, we know that our feed pump is running continuously. Then it can damage. It can damage. The impeller of the pump can damage. And that's why always the 10% of the volume of water, 10% volume of discharge water. This is a discharge side of the pump is returning back. Returning back. So the back pressure is not going to be applied on the pump. Means when it is shut, so full back pressure will be there in this. Impeller may get damaged. To avoid that one, this 10% is continuously returning back. Okay, so this is the arrangement we have for the continuous boiler water level control. Any doubt to anyone? Okay. So that's it about this one. Now next one we are going to see, that is okay. Next one we will be seeing here, that is the boiler I have completed. Next I am going to take the steering gear autopilot, because autopilot is also an important one. And there are the many regulations are there, that also we'll see. But this regulation part I will keep it at last. Okay. And first we'll try to see the autopilot part. Now this is a PID control, so we'll be seeing this one. So you can take a 5 minutes break, then we'll continue this.
Sir, boiler safety.
Okay. Welcome back.
Excuse me, sir.
Yeah, tell me.
So boiler safety is when you will teach us.
Safety parts is taken by the Abhishek sir. So he will be taking all the subjects.
So about electrical safety is also
Yes,
or
electrical safety.
and sir, one more thing about this flame inside this boiler, how to means what all problems we can face with this.
Flame. Yeah. Flame problems you are going to have. See, I hope everybody know about the firing sequence. Do you know the firing sequence of the boiler? Anyone? This is important. If you know the boiler firing sequence, you'll come to know about these problems what you are going to get also. So let's see with the firing sequence. Now, firing sequence starts with the standby. So first we are going to have the standby. Let me write this one. So now we are seeing a boiler which is going to have auxiliary boiler we are seeing here. Okay, auxiliary boiler firing sequence I am going to tell you. But this auxiliary boiler is having both the burner, pilot burner and main burner. I will tell you the difference between only if the main burner is there and pilot burner is not there. I will tell you, but sequence remain almost same. So there is no changes in this one. It is sequence is going to almost remain same. If you understand this sequence, so if only the main burner is there, you will understand that. So firing sequence that is start with the standby. So system should be standby. Standby means no alarm. Any type of alarms are not there. No alarm. Okay. Now, when it is in the alarm condition, suppose it is in the alarm condition, it will be never be in the standby. So when it is in the alarm condition, you need to reset this one. So after reset, it is supposed to go to the after reset, it's supposed to go to the standby. Okay. Once it is standby mode, now a firing sequence will start, and this is going to start when your pressure, steam pressure, comes to start signal, that is the on signal, and that will keep suppose 5.5 bar. So at the 5.5 bar, when the steam pressure is there, this pressure when it is there, your firing sequence is going to start. And this is the firing sequence. In that first is the pre-purging. First is the pre-purging. Pre-purging means your FD fan is going to run continuously. FD fan starts and run. Second, your damper is fully open. Okay, now what the system we are talking here, we are going to have the ear damper this is solenoid operated, okay? Solenoid operated. Remember this one? And the valve, that is the FO valves, they are also solenoid operated. Nowadays, you have got these two dampers in the new system, Albor. At least I have worked with the Albor, so I know. These two systems are having the servo motor. I will tell you about this servo motor, how it is working. If you know these solenoid operated dampers, air dampers and the valve, you will also come to know about the servo motor parts. Sorry. So, it will go to the pre-purging, air damper is fully open, and C, that will be your FO pump. Your FO pumps. Generally, it is going to run, or it is going to start and run. So once it is on, it is always running only, and sometimes it starts and run. Some systems will find it is run, start and run. Some systems, as soon as from the standby, first the FO pump will start and thereafter. And some pumps it is continuously running, but it is going to circulate. Okay. It is not stopping. So FO pumps starts and run at this point. You are going to have the two solenoid valve. One is the FO bypass valve. These all are the solenoid valve. And second is a FO supply solenoid valve. So these both are off condition. Okay, off means now your fuel oil is being circulated. It is not going to the nozzle. Okay, it is being circulated. So this is how this will be the condition. FO pump is started, but through the bypass solenoid valve, it is going to go back. Means if it is not energized, solenoid valve is not energized, it will remain in the open condition. And if it is not energized, it is going to be in the closed condition. So this will be the condition, and they both are not energized. Okay, so this is the condition when they are not energized. So this is known as a fail-safe mode. Fail-safe mode. Okay. So in case if the power is also getting off, that means it will go to the fail-safe. This will open and this will remain closed always. So this is the not energized condition. This will be the valve position. So this valve, solenoid valve bypass is always open, and FO supply valve is always closed condition. Once the pre-purging timing is over, whatever the time is there, you can see in your manual. Generally 3 to 5 minutes are there. It varies, depends upon different type of make and models. Then it goes to the ignition. After this, so this timing is 3 to 5 minutes. I will write here. So this is the time. And it goes to the ignition. Now, because we are going to, I already have told you, I am having the pilot burner. So I will tell you that if pilot burner is not there, that also I will tell you. So during the ignition, FD fan will be running. FD fan is still running. Then air damper will come to the closed position. In closed position. It's supposed to come to the closed position. Then the DO pump is going to start. Starts and supply to pilot burner. And ignition transformer. Ignition transformer. This gate supply. Supply is on for this. So the electrodes are going to have the spark. So when it is supply is there, the spark in electrodes. Okay. This is going to happen when we are going to have the pilot burner. If pilot burner is not there, then what will happen? Same thing is going to be there. Every fan is going to run continuously. Air damper is going to come to the closed position. In servo motor type also it is going to come in the closed position. Here the DO pump is not going to start. Okay. But when the air damper is going to come to the closed position, your A4 supply valve, here the supply valve is there. This is now a regulating valve, regulated valve by the servo motor. Servo motor. Okay. Supply valve that is having fitted with the servo motor. So this valve is going to operate. Okay, so this is going to operate. 1 minute. The supply valve, that is the solenoid one. Solenoid one. One is the solenoid. So this is going to be automizing type. This is going to be on. Okay, it is going to be on. And once it is going to be on, and thereafter there is a servo motor is also there. A4 servo motor. So this servo motor that will be operated, and accordingly, because your air is not there, but this will, from the nozzle, it will manage the fuel in such a way that there will be in the proportion. So this is automizing, it will give the automizing, but it will be in proportion of air. Because air damper is closed, so in proportion of air, this servo motor is going to work. So accordingly, it will come to the automizing. So it is going to automize, and ignition, that D remains same here. So ignition transformer, this gate supply. So the spark is available in the electrodes. Spark in electrodes. Now here in this case, the main burner is going to have the flame. Main burner is going to have the flame. Okay. The oil flow and this all, if you have worked in the Alborg, you will come to know. But I need to tell you little bit if you have any confusion. Then this is the diagram for that. Yeah. Okay, if you see this, little bit I will go this side. This is what it is going to happen here. This one, this wall, this one is a A4 bypass wall. It is a A4 bypass wall. Then this one is a FO supply valve. So this will be there. This solenoid operated. So this both are solenoid operated. And here, this one is a preheater. This is a preheater. When it is going to come to the flushing period, that is the pre-purging time, flushing period, that is the pre-purging. Now you can see here, this is also operated, this is on, this one, this is going to be on. So this is on always, means it is not energized only, so bypass is still there. So it is bypassing, it is open only. Okay, so here if you see this one, this is remain open always. Oh, let me write with the red color. So this is always open and this is again, it is closed. Now when the flushing period is there, this remain open. Now this is going to energize and open. This is open and here this is also open here. So these two will be opening and through this servo motor. Can you see here the servo motor? Okay, I have not written here. I must write here. This one. This is the FO servo motor that is used. Servo motor. So now the fuel. So fuel is going. This fuel is going this side also like this. And it is also going now from here. It is going here. Nozzle is not operated, okay, remember. And it is going to flush through and it will come here through the regulator, it will again join here. Okay, so this is the how it is going to be there. Now when the automizing is there, in that case, this is going to operate, this one. This all are, now this, okay, let me tell you again. Now this is closing, so this is energized. This is going to open. This will remain open. And here, this one is also going to open. And this will be closed here. This one is being closed. So that here the piston is there. If you see here clearly, there is a piston. So this piston from here, this one, this red one here, now it has moved here, this piston. So when it is going to open by pressure, it is going to move this side. Now, whatever the FO is there, this is going to get automized. So this is the automizing period. So this is the during ignition it is going to happen. How much the FO will be passed through the nozzle, that will be this servo motor, how much it is going to open. If it is open fully, here will be very less pressure will be there. If it is going to be closing, more pressure is going to be here. So this is how it is going to regulate. If it is opening fully, less pressure will be here. If it is closing fully, full pressure will be there. So just opposite it is working, this servo motor. And again, this is the stop period. And during that one, this is what again it will come to the same, whatever it is there. Okay. So this is how this works. So do not go in so detailed. This is a very detailed one. Just remember this one because I have told you this because you should understand what is happening. Okay. So FD fan will be running, air damper in the closed position. Air damper itself is having a motor. Okay, so they are going to work with the motor itself. So motors are there for the air damper also. And this air damper plus the valve regulations that is there, that is going to work in proper combustion, means the proper combustion should take place. So it is going to work in that way. Just I will tell you about this air damper also a little bit. Just I am going to tell. So at least you understand that. So here is the figure. These all figures are there in the album. You might have seen also. I have taken from that only. Sorry. So here, okay, it has gone down a little bit. Let me make it go up. So here the A and B position, what is showing here, okay, that is basically, this is your inlet, that is the A, and this is the B. Okay, this is like this. Here, this is showing here, but here it is given in this point. So this is a servo motor, 3 oil regulator. You can see here oil regulator. 4 is a dodging this one nozzle, whereas a 5 is a dodging shaft and 6 is a servo motor. So this is how the oil is going back. Okay, oil is going back to this one. Now, sorry, here, here we are going to have the C. C means the air. So air is going from here to here. So this is going to come through the FD fan, and this is the damper, and this is the servo motor for that. You can see as this one is going to open. So air and oil, this ratio has to be always maintained. So this ratio, this should be constant always. This ratio has to be constant for the proper combustion. Otherwise, there is going to be a black smoke or white smoke. The smoke or exhaust should be colorless. Exhaust should be colorless. Colorless when it is running. Okay, it will be colorless. Not during starting. During starting, it is always as a black exhaust. But once the firing is started and your boiler is in operation, it should be colorless exhaust. So that's why these servo motors are there. So they always has to have the one ratio of both.
But these dampers are in closed position when burning.
Sorry?
The damper should be closed when the boiler started burning.
No, during ignition, not burning. So air damper should be in the closed position. DO pump, in case of pilot burner, it is going to start ignition. Ignition electrode will be there in the pilot burner. This electrode will be there in the pilot burner. So this spark will be there in your electrode. Okay. Now next is after this ignition. So ignition takes place, then there will be the detection of flame. So next is the detection of flame. So detection of flame is done by the flame eye. Correct? So flame eye is going to detect the flame. Detection of flame. So this will be done by the flame eye. Flame eye is going to send the signal to the flame detection relay, FDR. Okay, and once the FDR is on, this is going to be on, FDR is on, then the next sequence will start. Next sequence will start. If the flame is not there, In that case, you are going to get a ignition failure alarm. Ignition failure alarm. This is the alarm. This is the first alarm you are going to get. Ignition failure alarm. Okay. Now, if suppose it is detection of flame is already there, FDR is there. After the detection of flame, there will be the changeover. Okay, it is going to change over. So if it is there now, detection of flame, suppose for 10 seconds, flame is available. For 10 seconds, flame is available. Flame is present. In that case, now the FO supply valve. So this will energize, and main burner is going to have the FO. And same time, the FO bypass valve will close. So bypass valve, this is going to close. Okay, let me write here, open and close. So this is going to open and this is going to close. So main burner is going to have the FO. And circulation will stop. No circulation. So this is what it is going to happen. Now, during this period, if the flame is present and flame is supposed to be there in the main burner now, as well as it's supposed to be there in the pilot burner, both. But due to some reason, if the flame is not there, in some system they have given one more here after the ignition. Once it is ignited, flame was there. But during the changeover, if the flame is not there, okay, then it is going to give a misfire. Sometimes the misfire and ignition failure are same only. We generally refer this misfire or ignition failure is same. So there is nothing new in this. It can be same also. But generally, if it is a separate from the ignition failure, and this is not an alarm, this is alarm and trip also. Misfire is also the alarm and trip. So this is separately, it is given in main boiler and all, you will find like this ignition failure. Thereafter the misfire also it is there. Okay. Then next is this flame. When the flame is detection of flame is completed, 10 seconds is completed, then next is there is a flame establishing time or flame safety time. Flame safety time. So after this 10 seconds, now the DO pump will stop. B, ignition transformer supply. This is stop. Okay, so there will be no flame now, no flame in pilot burner. It is not required now because the main burner is already running the flame. Okay, so here main burner, the main burner will be having the flame. Flame in main burner plus pilot burner. Both are going to have at this period. So already now, so no flame in the pilot burner, only in main burner. Now flame safety time, thereafter, once it is coming, it is some 2 to 3 seconds or 5 seconds, or whatever it is there. Okay, we can say 5 seconds or 10 seconds. Suppose we take 10 seconds. So after 10 seconds, now there will be the burner control, that is the flame control. So flame, high and low control. This is the burner control. This will go. So system will go in this. Now flame high control in this case, the fuel servo motor, if it is there, or the solenoid that is there. So whatever it is there, fuel will be given. So more fuel to the burner. And damper is going to open fully. Damper opens fully. Okay, so this will go to the high fuel and high flame. And when it is going to be low flame, so it was low flame here. Now it will go to the high flame from there. Again, when your pressure is going to reach, now pressure, what is the pressure we have chosen here? 5 bar. Steam pressure. So it is going to work in something like this. 5.5 bar. This is started. The system firing sequence is started. And it will go from here to the 7 bar, suppose. So this oil fire burner should stop at this point. So this is the stop and this is the start. The burner will start and it will stop here. Now generally when it starts and thereafter from here, now suppose we choose here something like 6.5 bar, we'll choose here. So till this point, it is going to be in the high mode, high flame mode, high flame mode. And thereafter, when it is 6.5 bar to 7 bar, it will go to the low flame mode. Low flame mode. So this is the high flame and low flame mode. This is basically a fuel and the damper. If it is a solenoid type, solenoid is going to operate, and if it is a servo motor type, servo motor is going to be there. So the fuel and air ratio is always maintained. Remember this. Is always maintained. So your fuel, if it is going, your damper is also going to open that. So it is a high flame mode or low flame mode control, it will be there. Now once the pressure that is going to reach to the 7 bar, thereafter the burner is going to stop. So it is going to stop, burner will stop here. And if it is going to shut down, so there is a shutdown means trip. So trip can happen or shutdown can happen from any position. Okay, so here something like that, yes and no, you can give here. If it is a no, then it will go to the trip. If any alarm, it will go to the trip. So we cannot say it is from here, it is going to be from here also, it will go to the trip. So I am just not giving anything. So if any alarm is going to come and trip has happened, it will go to the trip. And if everything successful, it will stop here. Okay. So flame is going to stop here. Means stop means 7 bar. It is going to reach. Flame is going to stop. How the flame is going to stop? The same bypass valve will open FO. FO bypass open. And the FO supply valve closes. Okay, so flame is going to stop. And as soon as it is stopped, thereafter it will go for the post purging. In the trip condition also, it will go for the post purging. Remember this one, it will go for the post purging. After the post purging, here the FD fan is going to run continuously. FD fan runs and air damper opens fully. Air damper opens fully. After the post purging, again it will go to the, either it will go to the alarm condition if it is a trip. If the trip, then it will be alarm condition. And after the post purging, if it is everything normal, it will go to the standby mode. Okay, so this is the firing sequence. Now, the alarm which is going to come after the flame safety time. Okay, when it is in the flame high and low control, if any alarm is going to come, if the flame failure is there, that is the flame failure alarm and trip. Okay, so that is the alarm that is going to come. Flame failure, alarm and trip. So this will come after this. So here means there is a flame safety time. And after the flame safety time, if any alarm is going to come, this will be the flame failure alarm and trip. This will be there. Okay. Now, what could be the reason that flame is not there? Flame failure alarm, the reasons are many. I will give you 1, 2, 3, whatever is there. So, if the question is being asked, you can answer that one. Okay. So, flame failure alarm, if you see, first let's see about the ignition failure. What is the ignition failure? If it is there, what is the causes of that one? Main causes of the ignition failure of this one is transformer. That is the HT transformer is there. HT transformer is bad. That is the chances is very, very less. Okay, but HT transformer, the cable that is there, and this cable is, if it is having a low insulation, this is a problem. Okay, so that means spark is not going to be fully, it will be there. Okay, so HT transformer plus cable, it should not have low insulation. HT transformer is also should not have low insulation. Low insulation generally when the this insulation material breaks down, so low insulation will be there, and the cable which is connecting. This is also the HT cable. HT cable. These cables are very soft. HT cables are very soft. Remember that one. So whenever you handle this HT cable, the insulation on top of the cable is very soft material. So try to handle very lightly. Means you should not give any hard turns or something. Anything you should not do it because this is going to break down. So low insulation will be there due to this. This is the one reason. Most common reason is this. Second, the electrodes are dirty. Electrodes are dirty. And this dirty is not that you are not cleaning. No, nothing like that. If your oil, if FO is dirty, then this is a very, very problem. And if you take from your bunker from the Fujairah and Singapore, This is the worst condition you are going to have, and you are going to have a problem if your purifier is not purifying your FO. So all are going to have a problem. First, your purifier is going to give a trouble, then your backwash filters are going to choke again and again. So this you can analyze the problem is there with the FO. Okay. So if this engineers are talking about like filter is choking or purifier we have to run or purifier we have to run in series, means two purifiers are there, we are running in series. Your mind should click. Okay, there is a one problem that is going to come in the electrode also. Remember this. So FO is dirty, this is really give a problem to us. That is, and second, on that gap adjustment. Okay, gap adjustment. So gap adjustment, do it as per the manual. Okay, so this will be okay. Only the FO is dirty. That is the very, very problem. For the electrodes are going to be dirty. So this is one of the problem that will be there. And finally, dirty flame eye. This is not a problem because flame eye, if it is a problem, it will give always a problem, not only sometimes. Okay, so ignition failure. So this will be the problem. Misfire, if there is a alarm and trace of the misfire, okay, then also you should see this one. And this is due to the, again, dirty flame eye. Second is chalked line filter. There is a line filter in this one. This is a one cause, or water content in A4. Again, Fujairah fuel oil is very, very problematic. Water content in A4 is more. Purifier is not working or something issues with that one, then you are going to have a misfire. Means just ignition will be there, flame will be there, and thereafter no flame after 10 seconds. If this problem is going to be there, this is there, and one more problem that will come with your damper setting. Damper setting is incorrect. Because as soon as the damper is going to open, you will find flame is gone, misfire. So this is a problem. Do not misadjust this damper. During the commissioning, it is being adjusted and people are doing many nonsense in this damper. Don't do, if you do not know about the damper and all, don't do anything. That is the best way to avoid. At least you are not going to have the suspect. Damper setting incorrect should be the last option if everything you have done. And most of the time, your problem is with this. Okay, rather than the system is having a problem or damper is having a problem. Third, flame failure. So flame failure. So main burner, like suppose it has run for half an hour or 1 hour and suddenly flame is gone. Okay. So this is happening. If this is happening, again, there is a region that we are going to have the contaminated FO, fuel oil. I have written everywhere the fuel oil problem because this is really a problem. It gives a problem. Flame eye, dirty flame eye. Yes, of course, if the proper combustion is not taking place, your flame eye is also going to become a dirty. And this flame failure will be there. Then F4 temperature. Now temperature has to be conditioned. If F4 temperature is decreasing suddenly, then also this is going to be a problem. Preheater is choked. Now, how the preheater can be choked? Preheater, if you see inside the preheater, suppose this is a preheater. Here. We are going to have a coil. Okay. In this one, this is our pipe. This is the fuel oil pipe is there. This is the pipe, fuel oil pipe. So this is the inlet and this is the outlet. Oh, sorry. Wrong. I am wrong here. This is a heater. This is a heater, that is the supply we are going to give here. Three-phase supply that is given. This is the heater coil. And we are going to have the inlet. This is the inlet. And here we are going to have the outlet. Now, what happens after sometimes when the oil is passing and this heater is on and suddenly your FO pump is stopped. If it is stopped and your heater is on, if this thing is happening, in that case, this all will become a coal. It is going to become a coal. So it is like a stone. Okay, it is going to become a stone, like a coal. So if it is going, this FO, if it is passing through it is going to have a temperature, but this temperature is going to decrease suddenly. And this is the reason that your preheater is choked. This will be a problem. So your FO temperature is not maintaining. And this is the main reason for your flame failure. Okay. Otherwise, there should not be any reason why the failure is there. Once the flame is there, started, it's supposed to be there. Okay. Any doubt or any suggestion? Okay then. Thank you. Thank you very much. Good night to everyone.